Module 5, Research Methodologies in AI. 5.1 Experimental Design. Importance of experimental design. A well-designed experiment is crucial for drawing valid conclusions, comparing different AI approaches, and ensuring the reproducibility of results. It involves carefully planning and structuring the research process to minimize bias and confounding factors. Steps in experimental design. Problem formulation. Clearly defining the research question or hypothesis, identifying the variables of interest, and specifying the goals and objectives of the experiment. Data collection and pre-processing. Determining the appropriate data sources, sample size, and data collection methods. Pre-processing the collected data, including cleaning, transformation, and feature engineering, as discussed in Module 3. Model selection and development, choosing suitable AI models or algorithms based on the problem characteristics, data properties, and prior knowledge. Developing and implementing the selected models, considering factors such as model architecture, hyperparameters, and training procedures. Evaluation and validation, selecting appropriate performance metrics and cross-validation techniques as covered in Module 4 to assess the model's effectiveness and generalization ability. Comparing the results of different models and drawing conclusions based on statistical analysis. Controlling for confounding factors. Identifying and controlling potential confounding factors that may influence the experimental results, such as data biases, hidden variables, or environmental factors. Techniques for controlling confounding factors include randomization, stratification, and matching. Reproducibility and documentation, ensuring that the experimental setup, data, code, and results are well documented and reproducible. Providing detailed descriptions of the methods, assumptions, and limitations of the experiment to facilitate replication and validation by other researchers. 5.2 Hypothesis, Formulation, and Testing. Formulating research hypotheses. A research hypothesis is a testable statement that proposes a relationship between variables or predicts an outcome. In AI research, hypotheses often relate to the performance, behavior, or properties of AI models or algorithms. Types of hypotheses. Null hypothesis, H0. The default or no-effect hypothesis, stating that there is no significant difference or relationship between variables. Alternative hypothesis, H1 or HA. The hypothesis that contradicts the null hypothesis, suggesting the presence of a significant difference or relationship. Hypothesis testing procedure. Specifying the null and alternative hypotheses, clearly stating the hypotheses in terms of the variables and relationships being investigated. Determining the significance level. Setting the threshold, usually denoted as A, for rejecting the null hypothesis, typically 0.05 or 0.01, which represents the probability of a type 1 error, rejecting the null hypothesis when it is actually true. Collecting and analyzing data, gathering relevant data and applying appropriate statistical tests to evaluate the evidence against the null hypothesis. Interpreting the results. Based on the statistical test outcomes, deciding whether to reject or fail to reject the null hypothesis. If the p-value, the probability of observing the data given that the null hypothesis is true, is less than the significance level, the null hypothesis is rejected in favor of the alternative hypothesis. Common statistical tests in AI research. T-tests, used to compare the means of two groups or to test the significance of a regression coefficient. ANOVA, analysis of variance, used to compare the means of three or more groups. Chi-square tests, used to assess the independence or association between categorical variables. Wilcoxon rank sum tests, used to compare two groups when the data is not normally distributed. 5.3 Statistical analysis in AI research. Descriptive statistics, summarizing and visualizing the main features of a data set, such as measures of central tendency, mean, median, mode, measures of dispersion, variance, standard deviation, range, and distributions, histograms, box plots. Inferential statistics, drawing conclusions about a population based on a sample of data. This involves estimating parameters, testing hypotheses, and assessing the uncertainty or confidence in the results. Confidence intervals, a range of values that is likely to contain the true population parameter with a specified level of confidence, e.g., 95%. Confidence intervals provide a measure of the precision and uncertainty of the estimated values. Effect sizes, quantifying the magnitude or strength of a relationship or difference between variables. Common effect size measures include Cohen's d for comparing means, correlation coefficients for assessing the relationship between continuous variables, and odds ratios for comparing probabilities. Statistical power and sample size. Statistical power is the probability of correctly rejecting the null hypothesis when it is false. It depends on the sample size, effect size, and significance level. Determining the appropriate sample size is essential to ensure adequate statistical power and detect meaningful effects. Multiple comparisons and corrections. When conducting multiple hypothesis tests simultaneously, the probability of making a type 1 error increases. Multiple comparison corrections, such as the Bonferroni correction or the false discovery rate (FDR) control, adjust the significance level to account for the increased risk of false positives. This module covers the essential research methodologies in AI, focusing on experimental design, hypothesis formulation and testing, and statistical analysis. Understanding and applying these concepts is crucial for conducting rigorous and reliable AI research. By following sound experimental design principles, formulating clear hypotheses, and employing appropriate statistical techniques, researchers can draw valid conclusions, compare different approaches, and contribute to the advancement of AI knowledge. Additionally, emphasizing reproducibility and proper documentation ensures the transparency and reliability of the research findings.